We'll proceed in Jacobian fundamentals in calculus. We are calculating Jacobian. Jacobian, you are really a jack. Jack, I believe it is a kind of an adage where someone is very high, so that is called jack. So Jacobian, you are really jack. What we have seen in the Jacobian till now. So Jacobian, what we have seen is Jacobian is used in d surface area by dxy plane. I mean, Jacobian is a factor. Jacobian is a factor that is used to change one coordinate system to other coordinate system. That is called Jacobian. Like if I am changing xy coordinate system to theta r coordinate system. I'm not talking about xyz. Xy to theta r. If I take xy plane, then the differential in calculus there are three things. One is limit. So if I am talking about xy and function over x and y, fxy, then limit is generally the region in the xy plane. Xy plane has a region that is two-dimensional region. In that region, we have to do the integration. So integration has three parts. One is the limit, another is integrand, and then differential. So integrand and limit we can change. Integrand and limit we can change. But what about differential? Dx dy cannot be directly changed into d theta dr because x is function over theta and r. Typically x equal to r cos theta and y equal to r sin theta. If that is the case, then there cannot be linear conversion of dx dy d theta dr. Dx dy, it makes xy plane. It is talking about two dimensions. It's not as good as dx is separate and dy is separate. So they are one entity, that is xy plane, x axis, y axis, z axis. Similarly, theta r is a combination. If I place full combination change dx dy to d theta dr, I have to add something so that conversion should happen. That extra thing that need to be added is called Jacobian. So that Jacobian, generally what I can say is, if I have xy plane and I take an area there that is delta x delta y, if that area is infinitesimally small, then it is delta x delta y. Okay, that area is delta x into delta y. If that is the case, delta x and delta y, okay, if that is the case, delta x and delta y, then if I take theta r plane, then delta area in theta r plane in the sense I am drawing theta r in the xy. Please mind it. There are two things. One is xy plane and one is theta r plane. Theta r plane coordinate system. Theta r coordinate system is also Cartesian only. If I take like x-axis and theta axis and r-axis, they are orthogonal to each other. So there will be rectangular region. If I take xy plane, if I talk about dx dy, that is a rectangular region where width is delta x, height is delta y. I mean width and length is delta x and delta y. Similarly, if I go to theta r coordinate system, again it is rectangular only, where a small area region is delta theta and delta r. So still we cannot change, we cannot modify delta x delta y into theta r delta theta delta r. What is the problem? If I if I if I have xy plane, if I have xy plane and I have theta r plane, if there is a rectangle in the theta r plane, how this rectangle maps into xy plane? That is a circle. Circle is in coordinate system, the polar coordinate system, that is theta r. Circle is in xy plane, not in theta r plane. Theta r plane, it is rectangle only. This is the biggest catch in Jacobian. If there is a theta r plane, there is a xy plane, then in theta r there is a rectangle. If I talk about theta r plane, if I map that rectangle into xy plane, then it will be a circle. If I am thinking that my polar coordinate system theta r is a circle, theta r is not a circle. XY plane is a rectangular region, then theta r is also a rectangular region. Both are Cartesian only. If I draw a rectangle in theta r plane, if I map on the xy plane with the formula, this is called t, x comma y equal to t in braces theta comma r. T is the conversion function. Then x equal to r cos theta, y equal to r sin theta. If someone maps rectangular region from the theta r plane into xy plane, then that rectangular region would map as a circle in the xy plane. Now, if I take a small area here, that is delta theta delta r, that is a small region in rectangular plane in theta r plane, delta theta into delta r, that is delta area. That area will be a small area in a rectangle, in a circle in xy plane, mapped one. Now, if I take a small region in the circular region, then it has two sides. One is radius and another is arc. That is delta area. One is radius, one is arc. If that delta area, with if there is a circle, if there is a if there is a circle, if there is a circle, this circle is in xy plane, not on the theta r plane. Theta r plane is a rectangle only. That rectangle is mapped into xy plane as a circle. Mind it. If there is a kind of section here, this is center and there is a section. Now it is seen that it is a strip here, small strip of area. That is nothing but it is like this. And this area, if I take a small strip, this is the full radius. This is the full radius. I mean, this is the full radius. This is the arc. If I take a small region here, delta area, then this is, one side is this arc, another side is this arc. This is the small radius. This is delta arc and this is delta arc. This delta arc is this delta r. If this is the radius, then this delta r, if this angle is d theta, then r d theta into dr is the small area, r d theta dr. So delta x delta y can be mapped into r d theta dr in polar coordinates, and this is what is said, but unsatisfiable. No one would be satisfied that it is infinitesimally small and you're doing this. Here, mathematics is not imagination. Mathematics is not approximation, because small to very small approximation in picometer, in nanometer also, if it becomes millions in numbers, billions in numbers, then it will go in kilometer. So approximation will hit the brain at here or there. So Jacobian comes into the picture. How we can modify delta x delta y, that is a small rectangular region in xy plane, into polar coordinate system. The polar coordinate system is also Cartesian, that is delta theta delta r. What I need to place there so that delta x delta y will become delta theta delta r. Okay, so there it comes as if I say, if I have dx dy, that is nothing but d small bracket x comma y bracket close, dxy plane. Dxy plane is nothing but dxy plane by d theta r plane into d theta as per the mathematics. Now d theta r plane, I can numerator, I can write as d theta dr. Now this is Jacobian dx comma y by d theta into r. So what it says is that we have talked many times. So dxy by d theta r. So if I have a rectangular region in theta r plane and that rectangular region is mapped into a circular region or whatever region in xy plane. If I make one unit of area change, meter square, one unit of area change, meter square, millimeter, whatever the unit of area is, if one unit of area change, area may grow, area may shrink of the rectangle. How many unit of area change the mapped area on xy plane it is making? Theta r, one unit area change of a rectangle makes how many unit of area change in xy plane? Dx comma y by d theta r. Okay. Now here we came with a principle. We took an example where we have now if I have a xy plane, on top of xy plane I have a surface. If I take any point on the surface, if I take any point on the surface where surface is dependent upon xy plane, and here xy is dependent upon theta r, because x equal to function over theta, y equal to function over theta r. Now if it is xy plane, then on xy plane there is a function fxy, function over x and y. If I take any point P here, then dp by dx, any point P here, and draw a position vector, then dp by dx cross dp by dy is nothing but d surface area by dxy plane. What is d surface area by dxy plane? If this is a full plane surface area, then if I draw a small rectangle on the xy plane, small rectangle on the xy plane, this small rectangle go up and it maps into a region on the surface, not full surface, wherever it maps. In that region, if I take point P, then dp by dx cross dp by dy, it will result in an algebraic vector field dp by dx, because p position vector cross dp by dy, that is nothing but d surface area by dxy plane. If there is a rectangular region on xy plane small, this rectangular region is going to map in some area on surface. D rectangular region on xy plane, if there is a one unit of change in rectangular region I have taken on xy plane, how many unit of change it makes on the mapped surface? It is mapped through the function fxy. So dp by dx cross dp by dy is nothing but d change in surface area by dxy plane. Similarly, we are here doing, if there is a theta r plane and there is a xy, then there is a mapped one rectangle in theta r. That rectangle is mapped into xy plane. Here it is a circle in polar coordinate system. Then dx comma y by d theta r. This is what we are trying to calculate, right? Earlier we had dx dy, that is dx comma y, dx comma by d theta r into d theta r. D theta r is d theta dr, dx comma y by d theta r becomes now d, now that is similar to one unit of rectangular change. If I make it theta r plane, how many unit of mapped region it making change in xy plane? Same to as dp by dx cross dp by dy, what we have seen now. Now it becomes d, if I, now if theta r and xy, in this plane there is a mapped region here, that is a circle in polar coordinate system. If I take any point P here, then dxy, dx comma y, d bracket as x comma y bracket closed by d theta r nothing but, if I take any position vector P, the way xy plane z was mapped on top of xy plane. Now xy plane is mapped on theta r plane, or if it is a theta r plane, then xy plane is mapped on it. If I draw a small rectangle here, that small rectangle is mapped on xy plane as a circle. If I make a small one unit of change in this rectangle, how many unit of change I see on this circle? That is dxy by d theta r. If I take any point P on this xy plane, then dp by d theta, dp by d theta cross dp by dr, where P is xi plus yj, because any point on xy plane is xi plus yj, then it becomes d of xi plus yj by d theta cross dxy dxi plus yj by dr. Okay. Now x I can take as r cos theta, because this is the function we have personally used. Y as r sin theta. If someone do this cross product and calculate the magnitude as per, then it will come as r. So r d theta dr is the net conversion of dx dy. We proceeded in this and started calculating the partial Jacobian. Partial Jacobian is nothing but how I can calculate surface area of the mapped function. So if I have xy plane, on top of xy plane I have a surface, and this surface I want to calculate the surface area. If that is the case, then now for this surface area, to calculate the surface area, we have d surface area by dxy plane. dp by dx cross dp by dy gives d surface area by dxy plane. But this is d surface area by dxy plane. If I want surface area, I have to multiply it back by dxy plane. Then only it will come as d surface area. So algebraic, this kind of thing direct is not possible. We have to pass through calculus. So d surface area by dxy plane I have to it will result into a vector. Vector magnitude I have to take so that it will be transformed into algebra, pure algebra. And then numerator is dxy dx dy. If I do this, then it calculates the surface area. But what about like cone example? We took example of a cone, right? If there is a cone, if there is a cone, okay. So repeatedly we are drawing the cone, and every time I'm losing the kind of shape what I used to take. Now I don't have that. Okay, so probably I have something different for the cone today. So I have a cone. So like we took example of a cone, right angle cone. Right angle cone means this cone falls on xy plane. This cone when falls on xy plane, it completely covers the xy plane. That is a right angle. Now this full is the diameter. This bottom is a circle whose radius is a, full diameter is 2a, and height is h. Now we are trying to calculate surface area of this cone. If we are trying to calculate surface area of this cone, then if I take any point P here, then dp by dx cross dp by dy, magnitude dx dy would give dp by dx cross dp by dy is d surface area by dxy plane into dxy plane, xy cut, we get the net surface area. This is what we want. So d surface area by dxy plane, magnitude dx dy. But if we took this, then it is very difficult. D surface area dp by dx cross dp by dy, where p position vector is xi plus yj plus zk. If we see the z variable, because z is dependent component, x and y are independent component. So if z is dependent, what is dependency over x and y? The formula, like a sphere, x square plus y square plus z square equal to a square. So z equal to square root of a square minus x square minus y square. What about the cone? So if I take the cone, if there this is radius and this is the height, it forms a triangle, radius a and height h. There is a slant height, perpendicular height, radius a. Okay. Now, if I take any height z, momentary height z, and at z, if I make a cross section, there is a circle again. That is radius r. So r is variable, z is variable, h is constant, a is constant. Now a by h is r by this height, that is h minus z. So a by h equal to r by h minus z. So h minus r by h minus z equal to a by h. H minus z equal to h into r by a. H into r by a equal to h minus z. Z equal to h minus r into h by a. So z equal to h minus h by a into r. R is, if I take cross section and there is a radius r, then radius r would rotate full 2 pi degree angle. At any moment, it is at angle theta from the x-axis. If this is x-axis at the cross section and there is a radius that rotates 2 rotate 2 pi degree. At any moment, it will be angle theta from the x-axis. So x is r cos theta and y is r sin theta. So z equal to h minus h by a, r is the square root of x square minus y square. If I see dp by dx cross dp by dy, then p is xi plus yj plus zk. dp by dx is I plus dz by dx k, and dp by dy is j plus dz by dy k. Now dz by dx is very different. Z equal to h minus a, h by a square root of x square plus y square. Then dz by dx, dz by dy, doing cross product and calculating the magnitude, then doing integration with dx and dy. It is something like hitting head against the wall. Now conversion comes into the picture. We are talking about partial conversion. Last two video we talked about the partial Jacobian only. Now instead of xy we will take theta r plane, xyz theta r z. So that is cylindrical coordinate system. Now we will convert all xyz to theta r z. So z is z, there also it is perpendicular one. xy would convert into theta r. Now the concept is dp by dx cross dp by dy, dx dy. So dp by dx cross dp by dy is nothing but d surface area by dxy plane into dx comma y, that is dx dy. Now again I can rewrite as d surface area by dxy plane into dxy plane, whatever we have now, by d theta z. I'll talk about why it is theta z, by d theta z into d theta z. Theta z we are taking because in calculation of cone surface area, we are talking about calculation of cone surface area. Calculation of cone surface area. Cone surface area. This surface area, the calculation of this surface area, if I see, then it has vertical side. Any area on this cone will have two sides. One is vertical side, that is z, and one is the arc, that is theta. So we are taking theta and z, r we are discarding. We don't need r. That will come in volume calculation or surface area of the base, not the height. We want only slant region surface area. So d surface area by dxy plane into dxy is the actual Cartesian coordinate surface area. Now by d theta r into d theta r, xy gone. Now d surface area by d theta into d theta r, d surface area by dz, the d surface area by d theta z into d theta z. D theta z becomes d theta dz, d surface area by d theta z. Now why it is partial coordinate system? Because if I have theta z plane, if I have xy plane, then on xy plane we have a surface. Now surface is dependent upon the xy plane. We are discarding xy plane completely. Now the surface area comes directly dependent upon the theta z plane. Surface area dependent upon the xy plane. Xy plane is dependent upon the theta z plane. Now surface area, we are kind of surface area, this xy plane we are kicking out. The surface area on the xy plane is not directly depending upon theta z plane. This is called I'm sorry, this is not partial Jacobian. I feel very sorry about it. Since the beginning, I'm talking about partial Jacobian. This is cross Jacobian. We have seen partial Jacobian previous. We will see partial Jacobian today also. So this is called cross Jacobian. Cross Jacobian in the sense this is xy plane. On xy plane there is a surface area. Xy plane is dependent upon theta z plane. XY plane surface area is dependent. Now XY plane we are kicking out and the surface area is completely dependent upon theta z directly. This is cross Jacobian. If it is cross Jacobian, then d surface area by d theta z into d theta z, xy gone. D theta z is d theta dz, d surface area by d theta z plane is dp by d theta cross dp by dz, where p is in xy only. So xi plus yj by xi plus yj one vector by d theta cross xi plus yj by dz. Now xi plus yj, x is r cos theta, y is r sin theta. Now if I go with d theta, then it is r minus sin theta I plus r cos theta j after doing the derivation. Cross product with r cos theta I plus r sin theta j by dz. So the r is nothing but, if I see the r, then r is nothing but r equal to r by h, r equal to h minus z by h into a. That is the r, h minus z by h into a, as per the beginning what we saw. So minus d, so it will be by dz, means minus h by a, minus h by a cos theta I minus h by a sin theta j, cross product. So r minus sin theta I plus r cos theta j, cross product with minus h by a cos theta I plus minus h by a sin theta j plus zk. Zk is there. Dz by zk by dz is 1. So plus k. So minus h by a cos theta I minus h by a sin theta j minus plus k. If I do cross product of these two and calculate the magnitude, then it is coming, then can calculate the magnitude, I believe it will come as, we have some constant, and in variable it will come as minus h minus z. Then I have dz d theta. If I integrate this, then it becomes hz minus z square by 2. That will be hz minus z square by 2. Now limit comes into the picture. Why I took this example again? Limit we were kind of not complete. Now integrand is complete, differential is complete, differential d theta dr, and integrand is the cross Jacobian. Now if I take the limit, now if I want, now limit is in xy region is circular region. If I take the cone, the bottom side is a circle. That is the limit for the surface area in xy plane. That is x, that is a circular region. X is minus a to a, and y, if this is the, if base is the circle, on xy plane, then x is minus a to a, y is minus a to a. Now here the xy will change into theta and z. What is theta and z? Now problem here is, if you take this in z coordinate system, if you take this cone in z coordinate system, if this is a circle, at the center of the circle is the height z. Otherwise this side, it is height is 0. So we have to take the surface area of a quadrant only. There are 4 quadrants. One quadrant where the x and y is positive, second quadrant, third quadrant, and fourth quadrant. In first quadrant, we have height as 0, and then height is h. That quadrant we will take because it varies. Otherwise, height is same this side, this side. So one quadrant if I take, then z value if I take, then y I'll convert into z, and x I'll convert into theta. So y is, now if I convert the y, now what about z value? So z value we have talked, if r by h minus z equal to a by h as per the calculation, then z equal to h minus h by a into r. This is what we have seen. Z equal to h minus h by a into r. Now r is square root of x square plus y square. Now if I take this point, now y is this point, this is x-axis, this is y-axis. Now we're talking about first quadrant. Y is origin to A. If I take origin, then x is 0, y is 0. If that is the case, then z is h minus gone, h. That is the at center, z is h, obviously. And this side, x is a. So this side now we will, y is 0 and x is a. Now z equal to h minus h by a square root of x square plus y square. X is a and y is 0. Then x square root a by a cut gone h minus h 0. So z would vary h to 0. Z would vary h to 0. And what about x? Okay, now x equal to r cos theta, y equal to r sin theta, y by x equal to tan theta, theta equal to tan inverse y by x. Now at the origin, y is 0, x is 0, infinite, tan inverse infinite is pi by 2, and other point on x-axis is other point on x-axis is okay. Other point, I believe in z calculation I made a mistake. Means we were calculating z value from the y. Y is origin to a, origin to a. So origin we saw it is z, it is h. So z equal to h minus h by a into r. H minus h by a into r. R is the square root of x square plus y square. At origin it is h. If it is a, y is a and x is 0, then it is same as now it is 0. So h to 0 is the z. What about theta? Now x is varying from origin to a. If I take origin in calculation of x, then theta equal to tan inverse 0 by 0, 90 degree, pi by 2. If I take another point that is a comma 0, then it is 0 by a, that is 0. Tan inverse 0 is 0. So pi by 2 to 0 is x now, and z is h to 0. And now here whatever the integrand is dz d theta. If I calculate this, then we will get as pi by 4 into a square root of a square plus h square into 4, because all 4 quadrant I have to take, then it will come as now the pi a square root of a square plus h square. Someone can do it. Okay, what about, can I calculate this fundamental, can I calculate the, now this is called cross Jacobian. With partial Jacobian, we have calculated the volume of a sphere. What about the surface area of a sphere through partial Jacobian? Partial Jacobian means we will not do full-fledged Jacobian, not converting xy plane completely into another plane. One part I will change or wherever I need it. So what is the partial Jacobian as far as calculating the surface area of a sphere? So if I have a sphere, that a sphere is centered at the origin. If this is the origin, sphere is centered at the origin. Half of the sphere, top hemisphere, is above the xy plane, and bottom hemisphere is below the xy plane. Now this sphere, if I take any sphere, then the sphere is centered at the origin. So bottom hemisphere is below and top hemisphere is above. Now I am trying to calculate surface area of the hemisphere. If I take Cartesian coordinate, we will see the top hemisphere only right now. Now it is dp by dx cross dp by dy and magnitude dx dy and integration over the region. So if this sphere is centered at the origin, the region it will make on the xy plane as a circle. So x is minus a to a, y is minus a to a. That is the region on xy plane. dp by dx cross dp by dy and magnitude. So p is xi plus yj plus zk by dx I plus dz by dx k cross j plus dz by dy k. If I do cross product, it becomes minus dz by dxi minus dz by dyj plus k. If I take magnitude dz by dx whole square plus dz by dy whole square plus 1 square root. Now sphere equation is x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square. Dz by dx minus 2x minus x by square root of a square minus x square minus y square. Whole square, dz by dx whole square means x square by a square minus x square minus y square plus dz by dy whole square y square by a square minus x square minus y square plus 1 square root dx dy. If I settle it down, it becomes a square by a square minus x square minus y square square root a by square root of a square minus x square minus y square. A I can keep outside. Now it is integration over a circular region with circuit with radius a, and then 1 by square root of a square minus x square minus y square dx dy. Whatever I am going to talk partial Jacobian, it is not available anywhere. This is our easiness we are providing you that. So please support us. Plus 91 is India's country code and 9483160610. Plus 91 9483160610. So now the kind of dp by d now we came to situation where I have to calculate integration of 1 by square root of a square minus x square minus y square dx dy. It is impossible through Cartesian. So we will not convert dx and dy completely into any polar coordinate system. Again, someone would start sweating. But that much I don't need. Why you are doing this one? I consider coal was very difficult. That's why we converted. Now partial is off. Now rather than going for cross Jacobian, okay, for the surface area, we will go for partial Jacobian. Only x I will change. Now if I say x equal to square root of a square minus y square cos theta, where it is like a polar coordinate system where radius is the square root of a square minus y square. Then if I see dx dy is the differential. dx can be written as dx by d theta into d theta, where dx by d theta is what? That is partial Jacobian. X equal to square root of a square minus y square cos theta, then dx by d theta equal to square root of a square minus y square constant minus sine theta, that I will place here. So square root of a square minus y square dx by d theta, square root of a square minus y square minus sine theta d theta, minus sine, minus sine theta, and d theta came. Earlier it was dx dy, dx converted into dx by d theta into d theta. So dx by d theta is square root of a square minus y square minus sine theta, this much. So I will place there. Now 1 by square root of a square minus y square minus x square becomes 1 by square root of a square minus y square minus x square becomes a square minus y square cos square theta. All along I can take out square root of a square minus y square. It remains here is square root of 1 minus cos square theta, sine theta. Sine theta gone, square root of a square was square minus y square gone, only minus remained there. Then minus I can keep outside. Anyway, a I have kept outside. So minus a is outside now. Now integration of d theta, that is theta. Integration of d theta is theta. Now if it is theta, then I have to bring back into x coordinate system because limit is in x only minus a to a. So what is theta? So x equal to square root of a square minus y square, a square minus y square cos theta. Because it is very difficult to bring in x back. Let's change the x limit only. We can do. Let's change. We can try both ways. Let's change the limit. From x, let's make it theta. So if x equal to, if now x is minus a to a. Now minus a to a, that is x-axis where y is 0. So if x equal to square root of a square minus y square cos theta, we are kind of fixing the limit, then y I can take it as 0. If that is the case, then x equal to a cos theta. If x is minus a, cos theta equal to minus 1, theta equal to pi, and it is a, then theta equal to 0. So pi to 0 and d theta integration is theta. Pi to 0 means minus pi. Minus anyway outside was there, gone. So it is now a pi. Now it is a pi. Okay. So earlier it was a I had kept outside. Now it is, I believe I am right. Now it is pi a. Now integration of y dy from minus a to a, that is 2a. It becomes 2 pi a square of the top hemisphere. Full integration is 4 pi a square. So 4 pi a square is the surface area of a sphere. So easily we did with partial Jacobian. Someone will say, can we try again that bringing the d theta, theta is the integration, theta to x back. So x equal to square root of a square minus y square cos theta. So cos theta is cos inverse of x by square root of a square minus y square. Same thing would appear when we are fixing the limit. When we are fixing the limit stuff, y we will take it as 0. So cos inverse theta by a. So one will be pi, one will be then this theta limit d theta integration is theta. D theta integration is theta. Theta is nothing but cos inverse x by a square root of a square minus y square. Now y, if I take 0 for the sort of placing the limit, then it will be minus pi 1. So amazing, mind blowing, right? Or why someone cannot try partial Jacobian calculating the surface area of the cone? We use full-fledged Jacobian. Someone can try partial Jacobian in calculation the surface area of a cone. That would where z equal to h minus h by a and a square root of x square, a square root of x square plus y square. If that is the scenario, then someone can try. So dx, someone can change it to whatever, cos theta. And here it was square root of a square minus y square. We'll proceed on it. And then we will see the full-fledged Jacobian. We have seen now cross Jacobian, partial Jacobian, the difficult most part we did. Now full-fledged Jacobian we will see when we will calculate the volume of a cone or volume of a sphere. So that we will see. Please support us. Plus 919483160610 is the telephone number. Please do support us.